Do you feel the vibes?
All right, so in the last section, we learned how to graph a quadratic function, right? We are going to move past. This chapter is all about solving quadratic equations, right? And again, I've said this before, in math, we can do everything in three ways, right? We can solve everything in three ways: numerically, graphically, algebraically. Today we're going to focus a little bit more on graphing, or solving a quadratic equation by graphing. Okay, so we learned yesterday that the standard form of a quadratic equation is this: ax squared plus bx plus c equals 0. In order for it to be a quadratic equation, a cannot be 0, right? Because you can't have 0x squared, then the x squared term will disappear. Okay, now, we also said yesterday that the solutions of a quadratic equation are called the roots of the equation. One way to find the roots of the equation is to find the zeros on the graph of the equation, and the zeros are just the x-intercepts, okay? So the solutions of a quadratic equation are also called roots. To find roots, it's the same as finding zeros on the graph of the quadratic equation, and the zeros are the x-intercepts. In other words, x-intercepts, zeros, roots, solutions all refer to the same thing. Now, a quadratic equation, when graphed, gives you a parabola. And if the solutions are the x-intercept, then there are three ways for it to look, right? It can look like this, in which case there is one real solution right here. Okay, it just like hits the x-axis one time. Or there can be two real solutions when it crosses the x-axis twice. Or there can be no real solution when the parabola floats on top or on the bottom of the x-axis. Okay, so take a look here to find the solutions of each of these, right? So for the first one, the solution is also just the x-intercept. So we say this is what? 1, 0, and 6, 0. Okay, so now, when we are, okay, so when you're asked to state the x-intercepts, you would say 1, 0, 6, 0. But when you want the solutions, then you would say x equals 1, x equals 6. Do you see the difference? Yeah?
Is the y just irrelevant?
Huh?
Is the y just irrelevant right now?
Yeah. This, okay, this is the x-intercepts. So here, there is no solution. Here, the solutions are -4 and 4. So you can say x equals -4, x equals 4. Or you can say x equals plus or minus 4. Okay? Here, there is just one solution, x equals -7. Okay? All right, now, before we move on to the next page, take a look at, I don't know, A, right? Take a look at A. There is a solution here at x equals 6, correct? Now, what do you notice? Let's look at the y values. At x equals 6, what's the y value? 0. Okay, right before that, what's the y value? All through here. It's negative. The y values are all negative. Right after the x-intercept, all the y values are positive, right? So do you see that at the solution, the y values change between negative and positive, right? But if you look here, the y values change from positive to negative, regardless. In the case where there are two solutions, at the solutions, the y values change between positive and negative, right? So that is one way to determine if you have a solution. Now, it's not going to work every single time because, for example, does that work at the 0 for number D? No, it doesn't work for this one, but it does work for the other ones, okay? So let's go here. So sometimes we can estimate solutions. Sometimes, you can't find exact roots by graphing because let's say, the solution won't be x equals 4. It'll be like 3.172937472, right? But you can say, okay, it's somewhere between 3 and 4, all right? So you can estimate the solution by stating the integers between which the roots are located. All right, so look here. What you can do is you can look for where the y value changes from positive to negative or negative to positive, right? So for example, here, right? Do you see here? The y value goes from positive to negative. That happens between x equals -4 and x equals -3. So when it asks you between what integers would a 0 lie, one is between x equals -4 and x equals -3. And there is another one here, right? Another one happens here. So between x equals 0 and x equals 1. Okay? So you don't give the y values, you give the x values. Okay? So let's take a look here. Use the table of values to determine the location of the zeros in each quadratic function. Okay, so we look at the y values, positive, positive, positive. Okay, here it changes. So it's between what and what? No. -2 and -1. And where else? And then here, 0 and 1. Okay? All right. Okay, here. Sign change happens right here. And another one all the way down here. So, between, what's the first one? 0 and 1. 0 and 1. You got to give the x values. And 5 and 6. Okay? All right, go ahead and take out your calculators. Okay. All right, so in your calculator, we're going to put in this A, right? So go into your graph. So we're going to do negative. Remember, if you're going to do negative, it's this button that's red on mine, right? Left of the enter. -0.5x squared plus 6x minus 15. Here we go. All right, now we need to find the zeros here. Okay, there are two ways to do this. One is the following. One is using the menu and analyze graph. So menu, analyze graph, that's number 6. And I want to find the 0, right? Number 1. And again, same thing, lower bound. I bring this somewhere to the left of the 0. Enter, click the center, drag. Here we go. So x equals 3.55. And then if you want to find the other one, you do it again. So menu, 6 for analyze graph, and then 1 for 0. Now I want to find this second point. So I start by putting this line to the left of that second point. Anywhere will do. Drag past the point. Okay, now look at what happened. This is all sorts of like scrunched up, right? So I'm going to go grab it and move it away so I can read it. And it's 8.45, comma 0. Huh? Okay. All right. Sorry, we just put x equals 8.45. Okay? All right, so for the next one, I'm going to show you a different way. So what I want you to do is I want you to press Dock B and reset your screen. Press the calculator button. Okay, for this one, bring everything to the same side, right? So it's going to be 13 minus 4x squared plus 3x is equal to 0. So 13 minus 4x squared plus 3x. Remember, we're not putting in the equals 0. All right? Enter. Here we go. Now, look at what we're going to do. No, we don't put in the equals 0. Okay, so now we're going to do it by tracing. So we're going to go menu, press 5 for trace, 1 for graph trace. And now, look, you've got your cursor here. Now when you press the left and right arrow buttons, it will, what we call it, the word that we use is traverse the curve. So it'll like hop through the curve. And at each point, look at what happens. At each point, you see the coordinate? It gives you, the coordinate at each point. So take a look. I'm going to go back here. As you go to like the critical points, look at this one. When you go to the maximum, it actually labels maximum for you, right? That's the vertex. So now I'm going to go over. Don't go too fast so you don't miss it until it says 0. Look at that. It says 0, right? 2.22. So x equals 2.22. And now let's go back to find the other one, maximum again. 0, negative 1.47. Right? So 2 ways of doing that. All right. Okay, let's move on. Okay, so for example 4, it says to use the formula h equals v naught t minus 16t squared, where h of t is the height of an object in feet, v naught. Okay, so let's take a look at this. So we have an equation that's given to us, right? We're going to use this for the entirety of this problem. Okay, so h of t is the height of an object in feet. This is important, right? You want the quantity and you want the units. This, in math and physics, the subscript 0 is called naught. So this will be V naught. This stands for initial, right? So it's like V naught, Y naught, X naught. It's always initial. V naught is the object's initial velocity in feet per second. And then T is the time in seconds. Fabulous. Okay. Marta throws a baseball with an initial upward velocity of 60 feet per second. Ignoring her height, how long after she releases the ball will it hit the ground? What is the maximum height of the ball? Okay, so if there is an initial upward velocity of 60 feet per second, that means V naught is 60 feet per second. So it says, how long after she releases the ball will it hit the ground? So what are we looking for here? We're looking for time. And we're looking for the time when the ball hits the ground. What we're given is an equation for height. When the ball hits the ground, what will the height be? 0. So h of t is equal to v naught t minus 16t squared. So we want h of t to be 0 equal to v naught is 60t minus 16t squared. Okay? So we're going to put this in the calculator. So we're going to put this in the calculator. Let's do doc B here. Okay, so, okay, 60. Okay, instead of t, we're just going to put x as our independent variable. Minus 16x squared. All right, go ahead and put this in. Okay, look, you don't see anything, but I really do want to see what's up there, right? So, remember what okay, did I show you guys how to change this last time? So go over here, hover, click, click. I'm going to put on there, so look, there is like 60 feet per second. I'm going to go up to 60 here, even though, okay, my physics knowledge tells me to do that, okay? And now I just get a better graph. Move this around. Okay, so what I want here is the time when it hits the ground, right? So which of these points am I looking for? Yeah. Yeah, so basically what I want, it says, the question is saying, how long after she releases the ball will it hit the ground? So now when I'm on my graph, right? Okay, now I have a graph. What do I look for on my graph to get my answer? This, okay, why the second x-intercept? Right, exactly. The first one, okay, the height is 0, but that's where it started, right? And then it went up, and then it went down, and this second 0, or x-intercept, is when it hit the ground after being up in the air, okay? So let's go ahead and find that one. Actually, for me, this is easier, because I could just go to that point, right? 3.75. So here I say T is 3.75 seconds. Gotta put the units. Okay. Look at the next question. What is the maximum height of the ball? Maximum height of the ball. So now when I have this, my x-axis, my horizontal axis is the time, and this is h of t, the vertical axis is the height, right? So this maximum here, that's the maximum of the ball, right? So when I find that maximum here, okay, I get 1.88 comma 56.3. What do those two numbers mean? Yeah. Oh my God, that is the most perfect way to word that answer, if ever there was a way to word, right? That is it. 1.88 seconds after the ball is released, it is 56.3 feet above the air. So the maximum height of the ball
Wait, what? How's that possible? It's 60 per second. And
is 56.3 feet per second. Okay? Okay. Okay, so yeah, it's feet. So for the next one, a volcanic eruption blasts a boulder upward with initial velocity of 240 feet per second. How long will it take the boulder to hit the ground if it lands at the same elevation from which it was ejected? Again, what was the maximum height? So in this case, it's a volcanic eruption. In this case, it was a baseball. Both of them, right, when something is just being thrown up in the air, they both follow that same equation, V naught T minus 16T squared. So take a look at what we have here. We have an initial velocity of 240 feet per second. That's my V naught. How long will it take for the boulder to hit the ground? So we're looking for T. All right. So H of T is equal to 240T minus 16T squared. So let's see. This time I'm just going to put it like this without resetting, right? Let's see what happens. I go tab, press up. To delete this all at once, I just do control delete. And now it won't change anything until I press enter. So let me just put in 240T, or X rather, minus 16X squared. Enter. Oh my gosh. Okay, so we can literally see nothing, right? So I really need to change all of my windows here, right? Look at what a tiny sliver this is. So I'm going to go here to negative 10. I'm going to change this to negative 2. I'm going to go here, change this to positive 2. More than 2 it seems. Maybe I'll change it to, what, 20? Okay. And now I'm going to go up here and change this to maybe, oh, I don't know, 250. Oh, more. Oh, because it's a boulder. Oh, no, it's like 807 or something. It's 800. Okay, here we go. Look at how wonderful that looks. I put 1,000. No, it should. I'll take a look. Okay. But regardless, we're looking for the 0, right? So menu, analyze graph, 0. Okay, so I want this one. Here we go. So it's 15, 0. Huh? Well, no, that's not the top. That's this. That's the 15 seconds here. Oh, yeah. But we're gonna do that now. So let's see. So 15. So it's gonna be 15 seconds, right? That's when it hits the ground. And then what is the maximum height that the boulder reaches? Let's see. You know what? I'm just gonna trace this time. I know. So here we go. Maximum 7.5, 900, right? And obviously, okay, so it's 900 feet. That's the maximum height that it reaches. And obviously, look, the time when that happens is 15 seconds, which is exactly halfway to 15 seconds, which is when it hit the ground, right? Okay. So the maximum height is 900 feet. Yeah. Yeah, so it's like the horizontal axis, independent variable is t, and this is h of t. The y. The maximum height. Yeah, the vertex. The vertex. Yeah, it's the vertex. Of course, it makes sense. It's math. Yeah. All right, awesome. Yay. Okay, fabulous.
Press start.